Hello everyone, and welcome back to your channel of Math and Engineering Made Easy. Today we are going to start a very important, or we have a very important session about graphing transformed parent functions. Last time I showed you many commonly used parent functions. I think I forgot or I didn't include two of them. So I will start by just showing you these. The first one is basically f of x equals 1 over x. 1 over x, meaning if x is 1, you get y is 1. But if x is 2, you get 1/2 and then a quarter. And it gets, I'm sorry, a third, then a quarter, then a fifth, until the x-axis would be an asymptote. Also, when x gets small, like 1/2, you get 2. At 1/3, you get 3. At 1/4, you get 4. And you get a shape that looks like that. Again, both the x and the y are asymptotes. And then you say, what if x is negative? Well, if x is negative, -1, I get -1. 1 over -1 is -1. 1 over -2 is 1/2. And you get a mirror image of that across from the origin. And this is 1 over x. The next one is similar, but it's f of x is 1 over x squared. Okay, so if x is 1, 1 over 1 squared is 1. If x is 2, then that would be 4, and you get 1/4. So it looks like that, but it's closer to the x and the y axes. Oh, looks like it because we are not drawing it to scale. But when x is negative, x squared would be positive. So you get the other half is like mirror image across the y. So instead of this being down here in the third quadrant, no, they are first and second quadrants. So just, to let you know. So today we are going to look at transformations, and I told you we are going to look at three things: translations, dilation, and reflection. No, no rotation now, because you will need some trig and more advanced stuff to learn that, like matrices and stuff. So we are going to concentrate only on these three. So just to simplify, to give you rules, because I'm going to use a novel approach. Okay, I mean, it took me a while to develop this. It works easier than what you learn in school or in the books. Gives you the same exact answers, but it's easier to understand and see why you have some rules that tells you, if you have reflection and translation, you have to do this before that. And you will find that no, this method doesn't have any restrictions at all. It's pure algebra. Very simple. So we have to write three things you have to be careful about. If I add or subtract constants, and I will elaborate on that later, to the x or the y, not usually, that means we have a translation. So either I'm moving right or left along the x, or up and down along the y. Number two, if I multiply or divide by a constant, that is dilation, either stretching or shrinking. That's it. Number three, If I change the sign, meaning multiply by -1, this is reflection. And the reflection here is either about the x-axis or about the y-axis. Okay? So we'll take some examples and I will show you what we mean by that. So let's start with, here I have like 6 problems, but I have few more on the next page. So I'm not going to do all 3. I don't know. Should we? I think the nice ones. I will do number 2 for a reason. You will see it. I also will do number 6. And I'm between these two. This is similar because this one or that one. Don't know. Let's take this one, for example. So 2, 5, and 6. Because I don't want it to be long, and it's still going to be long, believe me. Okay, so what are we going to do? Listen carefully. Here it says f of x equals negative x minus 3 cubed minus 1. If I take all the signs and the numbers and throw them away, not the exponent, because the parent function here is f of x. I'm not going to use f of x. I'm going to say y so you don't get confused. Y equals x cubed. That is the parent function, right? If I take away the negative sign, the -3 and the -1, but for a reason to be, because this is the first time you do this approach, I'm going to put the x between parentheses like I have the x minus 3 between parentheses, okay? All what I see here is that the right-hand side has only the parentheses that contains the x, nothing else. So basically, I'm going to add 1 to both sides. And then I'm going to multiply by -1, both sides. So now the right-hand side would be x minus 3 cubed. And the left-hand side would be negative f of x plus 1. Do we agree? Okay. Now, the easy part. I'm going to look at the x. So I would say 4x. How do I make, between the parentheses, there is, forget about the cube because both have cube. I'm just looking between the parentheses. X minus 3, x. What operation should I do to the x minus 3 to become x? I hope you said you added 3, right? If I add a 3 to the x-axis, that means I moved 3 units to the right. That's it. That's all what I did to the x. Do you see how easy it is? Now, let's move to the left-hand side and say for f of x, which is the y. How do I make the left-hand side be just y or be just f of x? I cannot subtract or add because I have a negative sign. So the first thing I do, multiply by -1. When I multiply the y by -1, it means I reflect on the x-axis. Be careful here. If I multiply the y, I'm reflecting on the x-axis. If I multiply the x, then I'm reflecting on the y. Why is that? Because if the y is above, say y is positive, if I multiply it by -1, it becomes negative. It's going down. So I reflected that about the x-axis. But if the x is positive or negative, doesn't matter, and I multiply it by -1, I change its direction. So instead of being to the right, it would be to the left, meaning I turn my line or graph about the y-axis. Just keep that in mind. So when I multiply by -1, I got f of x plus 1. How do I make it f of x? Just subtract 1. Subtract 1, meaning move the graph 1 unit down. And I'm done. Couldn't be any easier, right? So, and you say, but how does that help me plot? Am I going to plot the x cube? Remember, the x cube was something that looks like that from the previous session. Am I going to, how do I move it and then reflect it and then move it? No, I'm gonna create a table, like a very simple table. In the first one, I'm going to do the parent function, meaning x and y. And I'm going to pick some values for x, some easy values that I know. For example, I know that let's not go to 3 because 3 cube is 27, and that would be very far. So let's do -2. I get -8. If it's -1 cube, it's -1, 0, 0, 1, 1, 2, 8. And here I'm going to do x. So this is my graph or my function. I'm going to do x and f of x. What did I do to the x? I simply added 3. I don't care about this is to explain what happened to the graph. If you are in the test or homework and they ask you, so what did happen to the parent function? And you would say, well, we moved it 3 units to the right, and then we reflected on the x, and then we moved it 1 unit down. But to create the table, I'm going to look at these. For the x, I add 3. See, -2 plus 3, -1 plus 3, 0 plus 3, 1 plus 3, 2 plus 3. Any easier? No. But for the y, or for the f of x, what did I do? I did two things. I multiplied by -1, then subtracted 1. Multiply this by -1, it becomes +8. Subtract 1, it's 7. Multiply by -1, it becomes +1. Subtract 1, it's 0. Multiply that -1, it stays -1. I'm sorry, multiplied by -1, it stays 0. Subtract 1, it becomes -1. Multiply by -1, it becomes -1. Subtract another one, it's -2. Multiply by -1, it's -8 minus 1 is -9. And I'm done. So now, if I have the graph, I can say at 1, oh, I'm sorry, I'm doing this. 1 is 7. 2 is 0. 3 is negative, this is 2, I'm sorry. 2 is 0. 3 is -1. 4 is -2. And 5 is -9. So my graph, remember, it has two turns. It is one of them, and then it starts to turn down. Remember, the original one was looking like that, and it was passing through the origin. I rotated it about the y, so now it's looking the opposite. I moved it 3 units to the right, so instead of going to the 0 at 0, I got to there at 3. Yeah, yeah, we moved 3, right? So the 0 became 3. So 3 and -1. And then I moved it 1 down. So instead of going to 3 and 0, it go to 3 and -1. And you can plot this and see it. Just quickly, I'm not going to do this for the rest, but just to show you. So the original one was x cubed, and this one is negative x minus 3 cubed minus 1. For the window, I will go, say, from whatever, -5 to 5 or something. We got to 5, right? So make that to 6 and make that, say, from -3. It's enough. For the y, I have -8 and -9. So let's say -10. And the maximum here was 7 and here was 8. So make it +10. And let's graph that. This is my original graph, y equals x cubed. And here is the one that is to the right and going down. Just to check, finally, to check these numbers, I'm going to go to the table and look at, I will start at -2. So -2, -8, -1, -1, 0, 0, 1, 1, 2, 8, and we didn't do 3, 27. But look at the other one. Notice the other one starts at x equals 1. So I have to start from here. 1 and 7, 2 and 0, 3 and -1, 4 and -2, and 5 and -9. So easy, right? Okay. Let's move to number 5. Number 5 says f of x equals the absolute value of x minus. If we have time, I will go back to this one. Well, to show you something, but it's not important. Well, it is important, but we may not have time to go there. Okay, if I take away the numbers, then oops. Then my parent function would be y equals the absolute value of x. Remember the V shape? Okay. Now you say, what happens for x? Oh, first of all, I want to make it like that. So I will have to add 2 to both sides, right? I'm going to add 2 and add 2. So now my equation becomes f of x plus 2 equals the absolute value of x minus 3. And that's a very easy one. Why? Because I'm going to say for the x, I want x minus 3 to be x. So I'm going to add 3, exactly like last one, meaning move 3 to the right. I'm done. How about f of x? For f of x, to make it y or to make it f of x, I only need to subtract 2. Subtract 2, meaning move 2 units down. Couldn't be any easier. I know the parent function, the x and the y, I can construct these tables very quickly, right? X and y. So I say -3, 3, -2, 2, -1, 1, 0, 0, 1, 1, 2, 2, 3, 3. Very simple. Absolute value. Now, how about my function f of x? Here is the x, and here is f of x. For the x, I added 3. So it's 0, 1, 2, 3, 4, 5, 6. For the y, I just subtract 2. So 1, 0, -1, -2, -3, -4, -5. It didn't take 5 seconds. So I come here and say 0 and 1, 1 and 0, 2 and -1, 3 and -2, and it's this straight line, right? So oh, I'm sorry. Here when we go to 1, we are subtracting 2. So that becomes -1, negative, or becomes 0, and then +1. I'm sorry. So you can see that at 3, after I got to -2, at 4, I go back to -1, at 5, I go to 0, and at 6, I go to 1, and I get the same V shape, but now instead of the vertex being at the origin, it had moved to 3 and -2 because I moved 3 to the right and 2 down. Very simple. one of the easiest graphs. Now, let's go to the last one here, and then I'm going to move to something new. Here, number 6 says f of x equals 2 to the x plus 1, and this one turns out to be easy also, minus 3. So here y equals 2 to the x. How do I make only the 2 to the power on the right? It means I have to add 3 to both sides. That's it. So I get f of x plus 3 equals 2 to the x plus 1. Okay, so for the x, all what I have to do to make that x plus 1 to be x, I'm going to subtract 1, meaning move 1 to the left. And for f of x, I'm going to subtract 3, meaning move 3 down. That's the description of what happened. That's what I'm going to use to create the table. For the parent, I have x and y, and I can pick easy values. So -1, 2 to the -1 is 1/2. I don't want to use fractions. So at x is 0, anything to the 0 is 1. At x is 1, I get 2. At x is 2, I get 4. At x is 3, I get 8. So that's same, okay? Here is my function. I have an x and f of x. What did I do to the x? I subtract 1. So -2, -1, 0, 1, 2. What did I do to the y? I subtracted 3. So -2.5, -2, -1, +1, +5. -2 is -2.5 somewhere here. -1 is -2. 0 and -1. 1 and 1. 2 and 5. And of course, now you can see that, again, something important. We say here the x-axis was an axis of asymptote. It's an asymptote or just an asymptote, right? What did we do to the x? We subtracted 1. So now x equals, so I'm sorry. When we say the x-axis, I mean y equals 0, right? And here I moved 3 down. So the asymptote here is y equals -3. Here is the -3. So this is the asymptote. And my graph would look something like that. I moved 1 to the left because I should get, at 1 I should get 2, and then at 2 I get 4. So I moved 1 to the left and then moved 3 down. And basically that's it. Okay, so we learn, oh, the only thing we didn't see here is the dilation. So let's see the next problems. If I don't see a dilation, I will show you one. Yeah, we do have dilations here. I'm not going to do these because these are parent functions. We did that last time. Let's look. Here they don't ask you to plot, but they ask you identify the parent function. So the parent function is y equals 1 over x. And then what are the transformation? What did I do to the x? What do I do to the x? Notice this is 1 over x, so I will have to say negative. I would multiply by negative to make it just to look like that. So I say for the x, I move 6 units to the left because I have to subtract. Notice we are doing the opposite, right? So I move 6 to the left. And for the y, I reflected on the x. So from up to down. Do you see that? It's very easy. Here, the parent function, we just did it. Y equals 2 to the x. What did I do? First of all, I have to subtract 3. So I moved 5 units to the right because I need to add 5 to make it x. And I will need to add 3 to make it y. So I moved 3 units up. Now let's go to this one and let's even plot it. The parent function is y equals absolute value of x, the v shape again. I'm going to subtract 4 from both sides. And then I'm going to divide both sides by 6. So I get g of x minus 4 over 6 equals absolute value of x. So I didn't do anything to the x. Here, by the way, someone can say, can't I bring the 6 inside and make it g of x minus 4 equals absolute value of 6x? Yes, absolutely. Now I want you to see something important. That's what I was going to discuss. You have two ways to proceed. You could have said, I didn't do anything to the x, but I multiplied the y by 6, meaning I stretch the y 6 times. Sometimes in the regions they tell you, does the new graph is wider or narrower than the parent? Well, if you extend the y, meaning the x gets narrower. If you compress or shrink the y, the x would be wider, right? So from here, I'm going to say multiply the x by 6. So I'm going to stretch it up and then add 4, meaning move the whole thing 4 units up. Here, I'm going to squeeze the x, shrink the x by a factor of 6. It's exactly the same thing. Let me, on a different page, show you both methods. So for the x, so this is method 1. For the x, I'm going to divide by 6, meaning shrink x by a factor of 6. And for the y, or for f of x, I'm going to add 4, meaning move 4 units up. Method 2, nothing for the x. For f of x, I'm going to, first of all, multiply by 6, meaning stretch by 6, by 6, and then add 4, meaning move 4 up. Let's create tables for both cases. So the parent is x and y, absolute value. But since I'm going to divide by 6, I'm going to use, probably I will go by 3s. So I would say -6, -3, 0, 3, and 6. Here, I'm going to divide by 6, so I get -1. Oh, the x, yeah, I'm going to divide. So here is x and f1 of x, the first method. And then I will do x and f2 of x, the second method. So let's concentrate on the first method. I'm not going to do anything. Oh, I'm sorry, that's f of, yeah. For x, I'm going to divide by 6. That's it. So I get -1, -1/2, 0, 1/2, 1. Okay? And for f of x, notice the f of x is that, right? The absolute value stays the same. So for f of x, I'm going to add 4. So the 6 becomes 10, this becomes 7, that becomes 4, that becomes 7, and that becomes 10. What about the second method? I'm going to multiply the x by 6. So my x would be -36, -18, 0, 18, 36. And you say the numbers don't match. I don't care. I will show you what I mean. And what did I do for oh, I'm sorry. I didn't do anything for the x. No, the x stays -6, -3, 0, +3, +6. And you say they are not the same, and I tell you it doesn't matter, as you will see. And then for the y, I'm just going to multiply by 6 and then add 4. So multiply by 6, I get 36. Add 4, it becomes 40. Multiply by 6 is 18, plus 4 is 22. Multiply by 6 is 0, add 4 is 4. Now I have 0, 4, 0, 4. Multiply by 6, I get 18, add 4, 22, and again 40. Now, let's do, let's clear that and clear that. I'm not going to write both. I'm just going to write the equation f of x is 6. And then I go to math, absolute value of x plus 4. I'm going to graph that, okay? And then I'm going to go to the table. And we started at -1. So no, let's go to -6. -6 and 40. And then I go to -1, -1 and 10. And then I go to 0, 0 and 4. And then I will go to -3, 22. I will go to, I don't have -1/2. You can change that in the settings easy, but let's wait for that or that. When I go to 1, I get 10. If I go to 3, I get 22. If I go to 6, I get 40. In fact, if you want that, it's easier even to go just to calc and say a value, and you put x is -0.5, and you get 7. Oh, sorry. And then you make it uh, 0.5, and you also get 7. So you see, we got everything as the table, and we had two ways to think about it. Sometimes you get that, sometimes. Okay. Uh, Maybe we can do the rest. We are not going to graph, just show what we did. So before I write the parent function, let me put this in, because I know the parent function is y equals x cubed, right? So I'm going to add 8 to both sides and then multiply by 4. So 4 times f of x plus 8 equals x cubed, right? So x cubed is x cubed. So I'm not going to do anything to it. Okay? And then for the y, I divide by 4. Notice it's 4. So you have to get rid of that by dividing. So shrink y by a factor of 4. And then subtract 8, meaning move 8 units down. By the way, don't do that. Don't do that at home or in class. I could have distributed the 4. So I would get 4 f of x minus 30 plus 32. So I could have said, no, I don't start by shrinking. I'm going to move 32 units down and then shrink by a factor of 4. Believe me, you will fail. They will give you wrong. 0, even though it's correct. But the way it's produced to you, unfortunately, and I hate to say that, in the books or in the curriculum, has they have you to follow a specific methodology, and that deprives you from looking at the graph from multiple like aspects or facets and see that, for example, I don't want to make it hard on you, but suppose I say y equals 4 x squared minus 3. So you say, okay, I'm going to add 3 and divide by 4 both sides, and I don't do anything to the x, right? Because you would say y plus 3 over 4 equals x squared. So what did I do to the x? Nothing. What did I do to the 4, to the y? I would multiply by 4, meaning dilate it by a factor of 4, and then subtract 3, and then move everything 3 units down. But can't I write it 2x quantity square and y plus 3? So instead of dilating the y by a factor of 4, here I shrank the x by a factor of 2. And you say, is it the same thing? Yeah, absolutely, because 2 squared is 4. And I moved the y only 3 units down. You can try it. I'm just giving you some example, you know. But you have multiple ways of describing what happened to the parent function because now you see it's simple algebra. I can do whatever I want. So I hope you like that. If not, then stick what you have to what you have at school. What if you already learn it and you master it, don't change. But again, you can use this method to check your answer, to check what it's really pretty straightforward. I think we are getting too late, so I'm going to pick one more. This is easy. We already did that. So let's do E and stop. So I would write it as there is a negative sign, so I'm going to multiply both sides by negative. Notice because I cannot bring the negative inside, I cannot distribute -1 because that would be I imaginary, so we don't go there. So negative g of x, I'm going to multiply, no, first of all, I'm going to add 3 to both sides, right? So g of x plus 3, and then I'm going to multiply by -1. So basically, I add 3. So I get g of x plus 3 equals negative x plus 1 squared. And then I'm going to multiply both sides by -1. Of course, I will have to put this between parentheses equals x plus 1 squared. The parent function is y equals x squared. So what do I do? For x, I'm going to subtract 1. So move 1 unit to the left. For the y, oh, I have to multiply by -1 first, meaning we are going to reflect on the x or about the x-axis. And when I do that, I'm going to move 3 units down, and that concludes it. How do you like the apples? Okay. So again, um, please let me know if there is anything that you didn't understand here or you think we did incorrectly. If you like this method, please let me know. And if you don't like it, also let me know so I can see if I should continue in this, in trying to make some changes to some topics that I don't like, make them, from my point of view, easier, but I don't want them to be confusing to you. So please let me know. And until I see you next time, I wish you all the best. Thank you very much for watching.